Fabulous chemistry minions, video number 7. We are rolling right along. Today we are going to define and make isomers. Isomers. So here's the thing about isomers. Isomers have the same number of each atom, but different arrangement in space. The picture at the bottom of the screen, this is that weird format where every time there's a cross in the line, there's a C. So there's 3 crosses, so there's 3 C's. There are 6, 7 H's and an OH, so 8 H's and an O. And then if you look, all 3 of these things have 3 carbons, 8 H's, and 1 O. But notice they are very different. One I have an an OH group on the far right-hand side. Then I have an OH group in the middle. And then I have no OH group. I have an O stuck in between C's. So these, by definition, are isomers. They have the same number of each atom, but they have different arrangement in space. And for us, that changes the things we've been doing. So we've been writing molecular formulas, and for isomers, the molecular formula will be exactly the same. Same number of carbons, same number of hydrogens, same number of oxygens, same number of anything that's there. But they're going to have different structural formulas, so hence I'm going to draw them differently. So then they're going to have different names and different properties. Okay, so the rule is they have to have the same number of carbons and hydrogens. So what I will not be able to do, and I didn't put this in here as the notes, what you will not be able to do is add or take away bonds. So if there's no double bond, I can't introduce a double bond. If there's no triple bond, I can't introduce a triple bond. But what I can do is move those things around. So and these are not part of my examples today, but if there is a double bond present, I can move it from the first carbon to the second carbon, and that would change things, and that would work, okay? So I'm going to give you 2 examples. First one is butane. So this is just a simple 4-carbon straight change, but 4 carbons, ane single bonded. There it is. And now if I'm going to make an isomer, I can't just add a double bond because that'll change the number of hydrogens that I have. But what I can do is create a methyl branch. And that's kind of what I'm hinting at here. And there's some hints along the way in the practice. One of the hints is wrong, by the way, and I never did fix it. So if I remember correctly, one of the hints will send you astray. If you're careful, you'll understand what I'm talking about. So if I make a methyl branch, what I do is I take this end carbon off and literally pop it up here onto the second carbon. So now the trick is, how many carbons is my main chain? Well, I'm going to show you right there. Now, if I take that carbon off, now my main chain is 3 carbons. So let's go ahead and build this guy. 3 carbons, take the methyl group that I cut off and put it up top. Then fill in with hydrogens. And now I have the same number of hydrogens and carbons. I have 4 carbons and I have 10 total hydrogens. But notice the structure is now different. The structure is different, so now the name is different. I got 3 carbons, single bonded propane, and then I have a 1 carbon side chain, that's a methyl. And where did I put the methyl? On the second carbon. So notice now, butane is what it looks like to have 4 carbons and 10 hydrogens in a straight chain. And if I make a side chain, it's going to be still 4 carbons and 10 total hydrogens, but now the name is 2-methyl propane. Notice the change in name, and then it's going to act differently. It's going to have different properties. Okay, so I have another one. This one I'm going to make 2 changes to. Okay, so first I'm going to start with just pentane. 5 carbons, single bonded, straight chain. Got it. And to make an isomer, I'm going to add a methyl branch. So I'm going to take this end carbon off, and let's put it right there. Let's put it on the second carbon. That leaves me, if I remove that end carbon, with a 4 carbon base parent chain. So let's draw that, a 4 carbon base parent chain. And then I wanted to move that methyl onto the second carbon. So let's put a methyl on the second carbon. Got it. Let's fill in our H's. And now we have this new thing. So now I have a 4 carbon chain. That's a single bonded ane. So that's butane. Then I put a methyl on. And where did I put the methyl? On the second carbon. So notice C5H12. The molecular formula has stayed the same, but the structural formula has changed. Therefore, the name has changed, and hence the properties will change. Okay? Now we can actually, because there's enough carbons here, and the more carbons, the more changes you can make, I can actually make one more change to this current structure to create a third isotope. And what I'm going to do is I'm going to add another branch. So I'm going to take this end carbon off, and I'm going to put it down there. And I'm going to make two methyls. That leaves me with this 3-carbon main chain or backbone. So let's start with that 3-carbon main chain. I already made a methyl on the first isomer, and on this one, I'm going to put a methyl on the bottom. There we go. So I have a 3-chain carbon with 2 methyls. Fill in my hydrogens, and it's going to look like this. Notice C5H12 still. And if I name this my 3 carbons in a straight chain, propane single bonded, then I have 2 methyls. So I have a methyl, 2 methyls is dimethyl. And where are the methyls? Both one is on carbon number 2 and the other one is on carbon number 2. So this is 2,2-dimethyl propane. So summarizing, how do I make isomers? I can make side chains from the parent chain, but I have to have the same number of carbons and hydrogens. What you didn't see is if there is a double bond or a triple bond present and there's enough carbons, like say 4 or 5 carbons, if it's long enough, I can move that double bond once or twice, and each one of those will have a different name, but the same number of carbons and hydrogens. Okay, so with that, we are done with isomers. Good luck with your practice.